In the previous episode, we explored the Georgina Basin, a vast petroleum province stretching across northern Australia, where hydrocarbons may have formed from microscopic organisms living in tropical seas before trees had evolved. It was an extraordinary story. A story about oil that didn't come from forests, about source rocks more than 500 million years old, about a basin that may contain billions of barrels of hydrocarbons despite receiving relatively little exploration. But after finishing that story, I discovered something even stranger. Because in parts of Queensland and the Northern Territory, the Georgina Basin isn't actually the deepest geological story beneath your feet. Hidden below it lies another sedimentary basin entirely, one that was already ancient when the Georgina Basin began to form, whose organic matter originated from cyanobacteria and other microscopic life forms living in Earth's oceans before animals existed, and one that remains so poorly understood that only 19 petroleum wells have ever been drilled across the region. There are no giant oil estimates, no billion-barrel discoveries, no certainty, yet hydrocarbons have already been found, oil staining has been encountered, and gas discoveries have been made. Recent seismic surveys have revealed sedimentary sequences up to 8 kilometres thick buried beneath northern Australia. For petroleum geologists, 8 kilometres is a serious number. That's enough burial to generate hydrocarbons, enough to create major petroleum kitchens, and enough to raise some very important questions. Because if the Georgina Basin was the story we could see, then the South Nicholson Basin may be the story hidden beneath it. And after more than a billion years, we're only just beginning to understand what might be down there. The South Nicholson Basin is one of the least understood petroleum provinces in Australia. That statement might sound surprising. After all, Australia has been exploring for oil and gas for more than a century. Thousands of wells have been drilled. Entire sedimentary basins have been mapped in extraordinary detail. Yet in northern Australia, there remains a region where geologists are still trying to answer some of the most basic questions imaginable. How large is the basin? How deep is it? What rocks does it contain? And perhaps most importantly, could it host significant petroleum resources? The reason these questions remain unanswered becomes obvious once you look at where the basin sits. Unlike many of Australia's famous petroleum provinces, much of the South Nicholson Basin is hidden beneath younger rocks, most notably beneath parts of the Georgina Basin itself. This creates an unusual geological situation. Imagine opening a history book and discovering that an entirely different story had been written underneath the first chapter. That's essentially what geologists found here. The Georgina Basin forms the upper layer, the South Nicholson Basin forms part of the deeper story, and that deeper story is far older. The Georgina Basin contains rocks deposited during the Neoproterozoic and Paleozoic. Many of its prospective petroleum systems formed around 500 million years ago. The South Nicholson Basin takes us much further back in time. Its rocks belong to the Mesoproterozoic. Many were deposited between approximately 1.4 and 1.6 billion years ago. The scale of that age difference is difficult to comprehend. Dinosaurs would not appear for another billion years. The first forests were still hundreds of millions of years away. The first fish had not evolved, and neither had the first insects and animals. In fact, the age difference between the South Nicholson Basin and the Georgina Basin approaches 1 billion years. The South Nicholson Basin was already ancient long before the Georgina Basin existed. Naturally, this raises an obvious question. If animals didn't exist, where did the hydrocarbons come from? Most people associate petroleum with forests, swamps, and lush vegetation, coal measures, river deltas, mangrove systems, environments packed with plant material. But none of those ecosystems existed when the South Nicholson Basin formed. Instead, the answer lies within Earth's ancient oceans. More than 1.5 billion years ago, marine environments were dominated by microscopic life. Cyanobacteria, algae, microbial communities, single-celled organisms. The world may have appeared barren from the shoreline, but the oceans were full of life. These microorganisms harvested sunlight and reproduced in enormous numbers. When they died, they remained settled onto the seafloor, year after year, century after century, million year after million year. Gradually, thick accumulations of organic-rich sediments developed. Those sediments would eventually become source rocks, and source rocks are the engines of petroleum systems. Without them, hydrocarbons cannot form. The remarkable thing about the South Nicholson Basin is not simply that it contains source rocks, it is that those source rocks originated from life forms that existed before animals had evolved. That alone makes the basin extraordinary, but source rocks are only the beginning of the story. Hydrocarbon generation requires burial. The organic matter must be subjected to increasing temperature and pressure. It must spend millions of years deep beneath the surface, and this is where the South Nicholson Basin becomes particularly interesting. Recent seismic investigations have revealed enormous thicknesses of sediment beneath parts of the region. In 2017, Geoscience Australia launched a major exploration program known as Exploring for the Future. One of its objectives was to better understand a poorly known region concealed beneath younger sedimentary cover. At the time, geologists recognised several large gravity anomalies within the area. These anomalies suggested that substantial sedimentary basins might exist beneath the surface. However, nobody knew exactly what was hiding there. To solve the mystery, Geoscience Australia collected a series of seismic reflection lines across the region. The results transformed understanding of the basin. Geologists discovered a previously unrecognised sedimentary basin approximately 120 kilometres wide and around 190 kilometres long. More importantly, parts of the basin reach depths approaching 8 kilometres. 8 kilometres of sediment is not something petroleum geologists ignore. Such thicknesses imply long-term subsidence. They imply prolonged burial. And prolonged burial creates the conditions required for hydrocarbon generation. As sediment accumulates, deeper rocks become exposed to increasing temperatures. Organic matter begins transforming, first into kerogen, then into oil. With sufficient burial, some oil may eventually crack into natural gas. The deepest parts of sedimentary basins become what geologists often call source kitchens, the places where hydrocarbons are generated. An 8-kilometre deep basin therefore immediately attracts attention, not because it guarantees petroleum discoveries, but because it contains one of the key ingredients needed to generate them. The seismic surveys revealed something else as well. The South Nicholson Basin was larger than previously recognised, and a previously unknown sub-basin was identified, the Carrara Sub-basin. This discovery highlighted just how poorly understood the region remained. For decades, geologists believed they broadly understood the basin's geometry. A handful of seismic lines fundamentally changed that interpretation. Imagine discovering that one of Australia's petroleum provinces was significantly larger than previously thought. That is effectively what happened. The implications extend beyond basin mapping. They also influence how petroleum systems are interpreted. One of the most interesting aspects of the South Nicholson Basin is that it may contain both conventional and unconventional petroleum potential. The unconventional story focuses on the source rocks themselves. In this scenario, hydrocarbons remain trapped within the rocks where they formed. Modern techniques such as horizontal drilling and hydraulic fracturing can potentially produce these resources directly from the source interval. This is the same general concept that transformed the Bakken Formation in North Dakota and portions of the Permian Basin in Texas into major petroleum producers. But there is another possibility, a conventional petroleum system. Hydrocarbons generated within source rocks do not always remain where they are formed. Oil and gas can migrate through permeable pathways, faults, fractures, porous reservoir rocks. If suitable traps are present, hydrocarbons can accumulate into discrete fields. Some of the world's largest petroleum discoveries formed in exactly this way. At present, geologists cannot confidently determine which scenario will prove most important within the South Nicholson Basin. Perhaps both are present, perhaps neither is significant. The problem is not a lack of geological potential, the problem is a lack of data. And that brings us to one of the most astonishing figures associated with the basin, 19. That is approximately the number of petroleum wells drilled across the region. 19 wells attempting to understand a petroleum province stretching across a large area of northern Australia. For comparison, major producing basins elsewhere in the world often contain thousands of wells. Some contain tens of thousands. The South Nicholson Basin has barely been tested. This explains why no widely accepted oil-in-place estimates exist. Unlike the Georgina Basin, there is no headline figure suggesting tens of billions of barrels. There is no giant resource estimate dominating discussions. Not because hydrocarbons are absent, but because there is simply not enough information. Hydrocarbon shows have already been encountered, oil staining has been recorded, gas discoveries have been made within related geological units. The petroleum system appears to function. What remains uncertain is its scale. How extensive are the source rocks? How effective are the reservoirs? How many traps exist? How much petroleum was generated? And how much remains preserved? At present, nobody knows. And perhaps that uncertainty is what makes the South Nicholson Basin so fascinating. Most petroleum provinces eventually become stories about production, field sizes, reserve estimates, well counts. The South Nicholson Basin remains a story about discovery, a story about hidden geology, about ancient oceans populated by microscopic life, about source rocks older than animals, and about a petroleum province buried beneath another petroleum province, and a story that may still be in its earliest chapters. Because despite the seismic surveys, the hydrocarbon shows, and a new understanding of the basin's geometry, the most important question remains unanswered. What exactly is hidden beneath the South Nicholson Basin? Until more wells are drilled, that question may remain one of the most intriguing petroleum mysteries in Australia. I hope you found this as interesting as I did. And as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.